Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over chemical changes and energy. So let's get into this. So when you're thinking about chemical changes and energy, you got to think about uh, the amount of energy that's in your reactants versus the amount of energy that's in your products. So whenever you have a chemical reaction, you're going to get a change in the amount of energy before and after the reaction. And if you end up with less energy in your products than you did with your reactants, then that energy had to go somewhere. So this is released to the environment. But if you have uh, less energy in your reactants compared to your products, if your products have more energy, then that energy had to come from somewhere. So it's being absorbed from the environment in order to make more energy in your products. So energy can't just come from nowhere. It's got to come from somewhere. And that has to do with, in part, breaking and forming bonds. So when you break bonds, that requires energy. You got to put energy in to break bonds. So energy is absorbed when bonds are broken. But when you form bonds, then that is going to release energy as well. So creating stronger bonds is going to make more energy get released and so on. So I'm getting a little bit ahead of myself. So let's go ahead and look at an example. So here we have water being formed from H2 gas. So I have two H2 gas molecules plus one oxygen O2 gas molecule, and that's going to form two water molecules in liquid form. And we see that energy is released during this reaction. Well, what does that mean? Well, if energy is being released, then that indicates that the bonds here for the reactants are weaker than the bonds for the product. Well, why is that? Well, if we think about the energy in the bond, right? So, and we think about potential energy. So we're talking about chemical potential energy. So in the same way, just like if I hold this dry erase marker, the higher above the ground that I hold it, the higher the potential energy, the gravitational potential energy. And the closer I hold it to the ground, uh, the lower the gravitational potential energy. So chemical bonds behave similarly. So you have these attractive forces between the atoms, right? So the lower the potential energy, then that energy is released to go somewhere else, right? So if I have higher potential energy, right, higher potential energy means that the bonds are going to be weaker, right? So maybe the atoms are not as close together as they should be. If they could get closer together, maybe that could lower the potential energy and strengthen the bonds, right? So there's this relationship between bond strength and potential energy between the atoms that are forming the bond. So weaker bonds are going to have a higher potential energy. The system wants to go, like natural systems, especially in chemistry, they want to go towards lower potential energy. They want the idea is to get as low energy as possible, lower potential energy as possible. And so, in doing so, you'll form stronger bonds, right? So, here, these bonds, the bonds in hydrogen and oxygen, are weaker bonds compared to that you find in water. So therefore, you have a higher potential energy here, but then you end up with a lower potential energy here. Well, you're losing energy, right? So if you start with reactants that have higher potential energy, and you end up with products that have lower potential energy, then they lost energy. That energy is released as a product. Okay? So what about this reaction here? So here I have calcium carbonate solid, and in this case, I need to put energy in order to get this reaction to go. So this reaction requires energy input so that the calcium carbonate can break down into calcium oxide and carbon dioxide gas. So again, if we look at this in terms of bond energy and potential energy, or bond strength and potential energy, we see here that we have stronger bonds here than we do here. So these have weaker bonds compared to these here. Okay, and so here we have a lower potential energy. So again, if you want to think of it in terms of breaking and forming bonds, well, if these bonds are stronger, that means it takes more energy to break them. So if I'm going to break these bonds, right, I need to put more energy in to separate the particles. So to break the bonds here, I need to put in more energy. Over here, since these are weaker bonds, when I put these together into their products and I form those bonds, energy is released. So when you form bonds, energy is released. If you break bonds, energy is put into it, right? So in order to break the bond, you need to add energy, and when the bonds form, energy is released, right? So stronger bonds require more energy to be released, and of course, if you form stronger bonds, more energies, did I say released? I meant energy absorbed. So the stronger the bond that I break, the more energy that's needed to break the bond, right? The stronger the bond I form, right? If I form a stronger bond, more energy is released in the process of forming the bond. So that's the relationship between breaking the bonds and forming bonds with regard to energy being absorbed or released. So once again, if I look up here, so these have weaker bonds, I'm breaking these bonds in order to get them to form this product. So in order to break the bonds here, it doesn't take as much energy because these are weaker bonds. So I have to put in a little bit of energy or less energy compared to the amount of energy that's released when I form the bond. So here, because I'm forming stronger bonds, more energy is being released compared to the amount of energy absorbed to break the bonds, right? And so if I'm releasing more energy here and breaking the bonds compared to energy absorbed breaking the bonds versus forming the bonds, then the overall is going to be a release of energy. I hope I said that right. So here, since I'm starting with stronger bonds in the reactants, I'm going to have to put in more energy here to break these bonds compared to the amount of energy that's released here because the bonds are weaker. I'm going to release some energy here, but it's not enough to balance with the amount of energy I had to put in to break the bonds in the first place. So therefore, an overall surplus of energy is needed to get the process to go. So here's another example. Sometimes the release or absorption of energy is given off in the form of heat or absorbed as heat. So in this case, when I form water, this is a exothermic reaction that releases heat energy, and I feel that heat. The temperature of the environment is raised during the process. Here, if I have ammonium nitrate solid and I dissolve that in water, right? If I take some solid ammonium nitrate and I put that in water and I dissolve it, well, that takes energy. And so what will happen is you'll see that the temperature will go down because it's absorbing heat from the environment and it's going to cool down the environment, right? So in this case, it would be an endothermic reaction. So this is the kind of process that happens in, like, say, a cold pack. So if you break the cold pack and you get the chemicals to mix, which is it could be ammonium nitrate in there, and it's dissolving, well, that requires energy and it's going to absorb heat from the surroundings. And so if you put your ice pack on your shoulder, right, then the chemical reaction is going to absorb heat from your shoulder and cool down the shoulder or your arm or whatever you need cooled down for whatever injury you have. Okay, so that's the idea between chemical changes, or I should say the relationship between chemical changes and energy. So let's talk a little bit about terminology here. So when I use the term exergonic, like for example, here, if I'm releasing energy, that would be an exergonic reaction. So exergonic means that any form of energy is being released by the reaction. So if the reaction is giving off energy, that's an exergonic reaction. If it's absorbing energy, right? So for example, here, this is absorbing energy. These ammonium nitrate being dissolved in water is absorbing energy. So we call that an endergonic reaction. Endergonic refers to any form of energy being absorbed. So if energy is being absorbed, it's an endergonic reaction. If energy is being released, it's an exergonic reaction. So exergonic versus endergonic. However, you might be familiar with the terms exothermic and endothermic. So here, when we use the term exothermic, we really mean specifically heat energy is being released. So in this case, what we mean by heat energy is that energy that's released in the form of heat that causes the increase of the kinetic energy of the molecules of the environment, right? So if you're releasing energy and that increases the kinetic energy of the molecules and atoms and the surroundings, well, that's going to raise the temperature because remember, the average kinetic energy, temperature is a measurement of the average kinetic energy of the molecules and atoms in whatever you're measuring, right? So that's what temperature is. So if you have an exothermic reaction, that means that reaction is releasing energy in the form of heat, and therefore that's going to increase the temperature of the surroundings because it's increasing the average kinetic energy of the chemicals, the molecules, the atoms in the surroundings. The opposite is true for endothermic reaction. So in this case, if you have an endothermic reaction, that is absorbing energy. It's absorbing energy in the form of heat energy. So this would be an example of an endothermic reaction. So this energy is heat energy being absorbed by the solid ammonium nitrate that's being dissolved in the water. So this process is absorbing heat energy. And so by absorbing the heat energy, it's lowering the average kinetic energy of the surroundings, and therefore it's absorbing heat. So absorbing heat, and then therefore it lowers that average kinetic energy of the molecules, and therefore lowers the temperature. And so that's how we can understand. Oops. Sorry about that. And so that's how we can understand the relationship between energy and chemical changes. So again, it really does have to do with how weak and strong the bonds are, and that's related to higher or lower potential energy. So again, higher potential energy means that the bonds are going to be weaker. weaker bonds means that it takes less energy to break. Or the other way around, you can think of it as, the weaker, the higher the potential energy, the weaker the bond. Then when you form that bond, less energy is released, right? So it all depends on the strength and weakness of the bonds and the higher or lower, how high or low the potential energy of those bonds are. I hope this was helpful. If this made sense to you, if you understood this, if this helped you in any way, please like the video, share the video, hit that like button over there somewhere. Also, make sure you subscribe to my channel, hit that notification bell. When you do hit that notification bell, make sure that you hit the all button or click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's anything that was unclear, ask away. I can try to clarify it for you. Also, if there's any topics you want me to cover, put that down below. If there's any particular question or problem you want me to help you with, put that down below. I would love to help you with that. Thanks for joining me and have a great day.